Let's see another data structure from the LeetCode. This is called Trie data structure. So in this problem, we want to add like different kind of word, like apple here for the example. Add the apple in some data structure, and then again you search, and if you find, then return true. You can search app, and it's not there, return false. So that's the problem. But we may think, why can we not use just a map where we can store different word, and then we can search that. So for this, map is good, like as long as that whole word present there, then that map data structure has map that works. But in this case, if you see this example clearly, there's an apple, and you can search that apple, and if it exists, returns true. App, that's return false. But there is something called start with app. So we want to search the word start with app. So in that case, the map data structure won't be efficient, because the map works in a way where the word completely exists as a key. So you can search that. If key exists, then you can return the value over there. But if you want to search something in a map, like a start with the app, then we need to iterate all this data, that is order of n, the traversal, and that won't be efficient. So that's why there is another data structure is needed here. That's a trie data structure. So you can read this definition. Trie is a prefix. Tree is a tree data structure used to efficiently store and retrieve keys in a database of a string. There are various applications of the data structure, such as autocomplete and spell checker. So in that case, we can use this trie data structure. Like for the spell checker, we type some word, and then let's type app, and then other, you'll see there's some suggestion. So those kind of applications we need the trie data structure. So we'll try to understand how to design this. So for this example, I have I'm going to design the data structure in this way. So I will create a node, and in the one node I will have two variables. One is letter to node map. So this is the map variable, this is the letter to node. So it's a letter to node, there's a one variable, another one is end. So, and this is end, we can make it false. I will explain you. And the last one is true. So this map can have the key like from A to Z. So this map can have 26 key. So we can store any value in this 26 key A to Z. So let's take for example app, and we want to store app in this trie data structure. Then we'll create a node, and as soon as we get A, then in this map at A we can store A as a key, and in the value we have another complete node. And then again in this node also there is a map that can again store any key between A to Z. So we have like P here, we want to store. So in a key P we can have another node, and in this node, so in this node also, this node can also store the key from A to Z. So again I want to store like P here, so I can say okay, let's have P here, this p, and in this time, this is the end of the word, then what I do, this variable I will make it true, and in this p I can store the key, this p, and again this p will point to another node. But in this time I'll just stop here, so is end I'll make true. So the next time, like if you search like just for the AP, then you will come here and they see, okay, A exists, so the key is A, and so it will come here, and in this map it will search the key A exists. So for that particular key, again you will get another big node, and we'll make it current here, this one current, and then from here again you see your another character exist or not, P. Okay, P exists. So in this P exists, we can return true as soon as we find like AP. So AP exists. Or if you want to search like complete word, then we can come here APP, and then we can also see if the end is true, then we can return true here. So this data structure we are going to design and solve the problem. So let's write the code. So I'll create the node here, like type is a try node struct, and here there will be two variables. I can say later to node map, and this is nothing but map. So map is, I'm saying byte because it's going to store A to G. So for that I can also say string also, but just making byte because this is going to store one character, byte, and that will be key, and the value will be try node itself. So this is the data structure we'll use here. And in this function, if you see this constructor, we need to fill the constructor. So constructor is going to return the try, and this is insert is function of try. So we'll call this function search function and start this function that will be called internally. So it will return this constructor return try. So with the help of this try, we can call this function. So here we need this object here. So let me put here, so I can just say this is the root. So this is going to return this try. And then try have, we can say the root, and the type is later to. This is a function, root, and we can say try node, and from the constructor return try, and it has the try has the root, so I can say the root. So I can initialize this root. So initialize this root. So for that I need this try node. In the try node we need the two variables. So one is this, another one is end. So you can say it's end, and this is the boolean. So come here, and the try node is end, and I'm not going to put any value for is end, and that will be false by default. So first time I'll just create the map for this. So try node, so letter to node map, and it's nothing but it's a map. key is byte, and the value is the try node. So I initialize this, and when we call the constructor, it will return the try. So from here I can say the current node is insert. In insert I can say current node is this and dot. So this dot root, because this is the object of try, so try has the root, so I can say root. And when I say that this dot root, that means it will return this dot root. So this root, it will return this dot root, and that will be nothing but our try node object. So that is current is a try node object. Okay, so this is the current, and then I can iterate through this word, like that. If the word has app, then I can say I0 I less than length of word I plus plus, and this we can take one. You can take the, if this word has the character app, then I will take first character a, word I, that is the a. You can say that's C for character, and I can check if that C exists in this current node or not. So this current node is this, so current dot, and the current is a try node, so try node has the map, so I can check in this map the key exists or not. That's for the app, let's say a, so a exists or not. So I can check current node map, and here I can check C. So C means that's a particular character A. So of course that will not exist in this case, and then so if it not exists, then we can add that key over there. So we can add the key. If it doesn't exist, then we can add the key here, and then also as a value we can store another node. So that's what we are going to do here. So I'll check current, okay. If not okay, then the current, so what we do, we add that value A as a key, so as a key, and the value will be this one. Value will be another node, so another try node, so just say another try node. So there is another try node, the value the A, and another try node, and that, that is the again the map. There will be two value, one is the is end, and that is false. So we created this node here, so that's node, so A and another node, and after that, as soon as we added the second node and we added A and the second node, we can make it current here. So we can make this current. So now this is our current, not a new variable, this is the same variable. We can make it current. So now we are in second node. So this loop iterate, and then we'll get another character from this word a P, and again for the P we can check that P exists there in this map or not. If it doesn't exist, then we can store P as a key in a second node P, and then for again we can create another node. So we'll do that, and A, P, P, and the last character we also store in a third node, and in a third node we are done because this loop, the word is done app, and then at the end will come and you can say current dot is end. That's true, that our word is true, that's it. So that means that's the complete word. The next thing is that's word need to be searched here. So let's write code for the searching. So the current, I can say this dot root, so that's the current. Now we want to search that word has app, and we want to search whether app exists or not. So we'll go to the first node, and in first node this map we put the key app. So for that we need a loop here again. So I can say for I is equal to 0, I less than len word I plus plus, and then c is equal to word I. So in this way we'll get one by one word, one by one letter app. Now we are going to search this a existed there or not. If it doesn't exist, then we can return false. So let's check that. Current letter current, and from the current letter to map I can just put this c, and if it exists not, I can have that logic. So if not okay, that means if it doesn't exist, then return false there itself. And after if, like if that word exists, then we can make the current, we can point that current to the next node here. So in this way you can go to the next node. So I can put this logic here. So we'll go to the next, and in this way we'll just find a p and the for loop end, and we'll check if is end true, that means we are at the end of this word in this data structure, and then we can return true, that means we found the word. So here come outside and just return current dot is end. So that's about the searching. For a start with we can utilize the same logic, and you can check the current test route. We iterate through this word app, and we want to just search maybe the example for app, just app, that word app that exists or not. So maybe iterate 2 times, and we can check here. If that doesn't exist, return false and move to the next node. And when this loop is done, then at the end we can just return true, because if it is not found, then it return false from the loop itself, but at the end we can just return true because we reached at the end. So let's run this. 25. Oh, this is the prefix, so this, the value is this prefix. I can just put it prefix here. Oh, this is also prefix. And submit this. Okay, so we are good. So this is the solution for this trie data structure. We can also see a Java example. So structure is same, the variable I put the different, so but you can understand that. But this is the node, and this is the map. I'm just saying this is the val instead of letter to node map. End of the word, another variable is end of the word, and in this class we have initialized this. and we have used the insert. And insert, again we have the for loop for the word, and we'll get the character one by one, and we can check if that character exists there or not. If it doesn't exist, then we can put that value, we can put that key and move to the pointer, so next, and the end of the word will make it true. And for the search, again there is similar logic, and when you reach to the end, then you can make that end word, one end character that is true. That means just say that okay, we are at the end of the word. Start with, again, the same logic. If you do not find, return false. At the end we can return true. So that's all for now. Thank you.